Assalamualaikum warahmatullahi wabarakatuh. We from Group 3 will present about Let Report ABS braking system. So my name is Muhammad Ahmad Zafar Bashirun. I will talk about objective of this lab. The first one is to familiarize with the tools used in balancing the wheels. The second one is to practice the correct procedure for balancing the wheels. Now for the lab procedures. The first one is the main power is turned on and make sure the digital display appears. Second step is the ABS switch is deactivated. The dry asphalt mode is selected. The wheels run at 15 km per hour. The brake pedal is pressed until the wheels stop totally. The braking time and stopping distance is recorded. Fluid pressure on front left wheel, front right wheel, rear left wheel, rear right wheel, and master cylinders is measured. The third step 2 is repeated for other real modes such as wet asphalt and icy or snowy. As you can see, the picture on the left is how you conduct the lab and all the steps that I read. For step 4, the ABS switch is activated, the dry asphalt mode is selected, the wheels run at 15 km per hour, the brake pedal is pressed until the wheels totally stop. The braking times and stopping distance is recorded. Fluid pressure on front left wheel, front right wheel, rear left wheel, and rear right wheel, and master cylinders is measured. Step 4 is for step 5. Step 4 is repeated for others real modes such as wet asphalt and icy or snowy. And lastly, for shutdown procedure, ABS switch is turned off. Wheel speed controller is adjusted until all wheels stop and the main switch is turned off.
And now we will be talking about discussion. So for the discussion, number one is component and function of hydraulic brake system with ABS. So for the main component, which include brake pedal to transfer the driver force to the hydraulic system, and the second one is master cylinder, which is to convert mechanical force into hydraulic pressure, and then brake fluid to transmit pressure to all wheel, and brake lines to carry pressurized fluid to each wheel, and a caliper or wheel cylinder, which is to convert hydraulic pressure into clamping force on brake disc or brake drum. And then we got a brake pad and disc, which is to create friction to slow down the vehicle, and the wheel speed sensor, which is to detect wheel rotational speed. And then for the ABS control, which is ECU, is to process sensor signal and control braking. And hydraulic modulator, or we call it a solenoid valve, which is to regulate brake pressure during ABS operation. And the last one is pump and accumulator, which is to restore and maintain the pressure during ABS cycling. So for the discussion number 2, which is operation of hydraulic brake system with and without ABS. We go for without ABS first, which is when the brake pedal is pressed, pressure from the master cylinder is transmitted equally to all wheels. If braking force exceeds tire road friction, wheel may lock, causing skidding and loss of steering control. And with ABS, wheel speed sensor detect rapid deceleration, lock up, and the ABS ECU commands solenoid valve to reduce pressure, to hold pressure, and to reapply pressure. This cycle occurs many times per second, preventing wheel lock while maintaining steering and stability.
My name is Muhammad Daniel Shazik. Okay, next. Uh, Third discussion. Braking time and stopping distance. All road condition. Okay. Dry alpha. ABS slightly increase stopping distance compares to locked wheel but maintain steering control. Wet alpha. ABS significantly reduce stopping distance, and improve stability. Ice and snowy road. ABS greatly improve controllability and prevent complete wheel tools. True stopping distance may still be long due to low friction. Overall, ABS provides shorter and comparable stopping distance and much better vehicle control, especially on lower friction surface. Okay, next, fourth discussion, fluid pressure observation. First, master cylinder. It has highest and most stable pressure source. Next, front wheel. It has higher pressure than rear due to weight transfer during braking, while rear wheel has lower pressure to prevent rear lockup. With ABS active, pressure fluctuates rapidly as solenoid valve modulate fluid to prevent wheel locking. Without ABS, pressure rises continuously and may cause sudden wheel lock.
Hello, my name is Abdul Qayyum bin Ahmad Shari, and now we will continue with question number 5. It is the improvement of ABS over a conventional braking. First, ABS can prevent wheel lockup. Then, it can maintain steering control during an emergency braking. Next, it can reduce skidding, improve vehicle stability, and optimize braking force on a different road surfaces. Lastly, ABS brake can enhance safety in wet and icy conditions. Next, we will talk about ABS and ESC regulation in Malaysia. Malaysia follows UN Vehicle Safety Regulation through JPJ and MIROS. Most new passenger vehicles sold in Malaysia are now equipped with ABS, which is the anti-lock braking system, and then ESC, Electronic Stability Control. So, since 2020, ESC has become mandatory for new vehicles, and ABS is already standard even in entry-level vehicles such as Prodwa, Proton, Toyota, and Honda. This has significantly improved road safety by reducing skidding, rollovers, and loss of control accidents. For now, that's all from us. Thank you.